So in 2.3 we start to use the multiplication and addition principles together. One thing that you can keep in mind is that the operations of division and multiplication will occur last when you're solving problems here. So we have 5x plus 3 is equal to 18, and we want to solve this problem here. Keep in mind what I wrote up here. The operations of division and multiplication will occur last. So what does that mean? What do we have to do? Right. And one thing I recommend is just putting a block around your x term, so that way when you keep this in mind, you know that you cannot divide first. Have to do it last. So minus 3 on both sides. And that's going to bring us back to 5x is equal to 15. And then now, right, divide the 5 off. So x is equal to 3. So again, this is our solution. We can check our solution. And our original equation. So 5x, so I recommend that you put that inside of parentheses just in case you have a negative number there. All right, then we do get 15 plus 3. So we have the correct solution. We have x on both sides of the equal sign. So how are we going to solve this?
Do 5x minus 21 equals 0, and then whatever that is equal to 8x.
Say that again.
It would be 5x minus 21 equals 0, and then whatever that result is, equal it out to 8x, and get your solution for x, and then plug them in.
Oh, okay, that is one way that you can go about it. Any other ideas?
Combine the terms.
What like which what where?
The 8x and the 5.
But they're on different sides though. We can only say combine if they're on the same side. So if I know what you're talking about, what you're really saying is that we can move this to the other side, right? How can we move this? By do right, because it's positive now, so we do minus 5x on both sides. So that way it cancels itself out over here. And we're left with 3x, right? Three x is equal to negative 21. And then what? Divide by 3, because the operations of division and multiplication will occur last. So dividing occurs last. So our solution, x is equal to negative 7. And now you're familiar with checking, so at this point, you know how to check by taking that negative 7 and substituting it back into the original equation. So we want to solve this. We have 11 minus 6 minus x inside of the 6x minus 1 inside of the parentheses is equal to 5x minus 2 times x plus 4. What do you think we have to do with this to get started? Okay, okay. If we go to parentheses, let's look at just the left side of the equal sign first. Go here. Nothing we can do on the inside, but what can we do? Well, yeah, we can distribute this negative, right? Because this is like a negative 1, right? So we can distribute that negative 1. So that becomes, we'll bring down that 11, and then negative 6x, and what? Plus 1. Right, negative times a negative gives us positive 1. All right, so we've eliminated the parentheses there. So we can go to the other side now, and what should we do?
Same thing.
Right. Take that. Let's bring down the 5x, and then 2 times x, negative 2 times x, negative 2x, and then what about here? Negative 8, right. Okay. That's good so far. Um, let's look at this side of the equal sign. And over here we can do, uh, what can we do? Right, we have 11 plus 1 there. So that gives us 12 from, from that. And then bring down the minus 6x. All right. And on the other side, right, so here we're going to get 3x out of that. Drop down your minus 8 from there. Okay. We have x on both sides of the equation.
It's easier to add 6 to both sides.
That's true. But for now, I want to just bring the x to the other side, to the left side. But you're right, you can do that. And so since we want to get x to the left side, we're going to do what with that there? So minus 3x. Actually, let me use this here. So that way it eliminates itself over there. So now we're going to get 12 minus what? Well, mm-hmm. Minus 9x because it's like adding two negatives together. So it's equal to negative 8 from this side. All right, and then we want to get rid of that 12 by doing what? So negative 9x is going to equal to negative 20, right? All right. And then divide off your negative 9. The negative has to come with it. So we have negative divided by a negative, which becomes a positive. So 20 over 9. Hmm. Yeah. So what if we have to change this to a mixed number? What would it look like? This is a improper fraction right now. That's what we call it.
2 and then 2 over 9.
Okay. 9 goes into 22 times. So we know we have that, and 2 times 9 is 18, right? So we have 2 left over. 2 left over 9. No, I just wanted to go through that example. In general, from this point forward, we'll be leaving our answers as improper fractions, like that. And okay. right, so go ahead and try this one out. We have 5 times 2 minus x inside of parentheses is equal to 8 minus 3 plus 6x. And we want to solve it for x. Go ahead and try that one out. So we can combine here, and that gives us, bring back down what we have here. Okay, x on both sides of the equal sign.
Subtract the 6x or add it.
Right, we do the opposite operation, so plus 6x. And that way, that cancels out. Again, here we get plus x, right? And is equal to 5. Where to here? From here. Right. So minus 10. So our solution.
Mr. Monk, I was always taught a trick for like multiple steps in an equation. You do it 1, 2, 1, 2. She called it the zinc-ing pattern.
Okay, yeah, yeah. Mm-hmm. Mm-hmm. You have a lot of tricks. So the goal is when we start working with parentheses, we start taking care of those parentheses first. And then if you eliminating the parentheses by distributing what's on the outside, and then combining like terms from there. Okay. All right. So any questions on anything from this section? One thing to just keep in mind is that if you have to divide or multiply, what is the case where we will have to multiply to solve? We know division, when it will be our last step. So when we have a whole number, we divide that whole number off in the last step. But what would be the case to use multiplication? For a fraction, right. When we have a fraction, we multiply the fraction, we multiply both sides by what? The reciprocal. So if this was a fraction, we will, instead of dividing, we will multiply it both sides by the reciprocal of it, or just by flipping it. So again, that goes back to the last section right here, where we had that fraction there connected to it. So in order for us to eliminate that fraction, we had to multiply it by its reciprocal. So whenever we're solving for x and we have a coefficient that is connected to our x variable or whatever variable we have, the operations of division and multiplication will occur last. So if you are working on a problem that has that in there, then that's what you need to make sure you follow.